Okay, great. So we are looking at the anatomy of agentic AI. In the last meeting, what we tried to do was to introduce everyone to what agentic AI means, what agents can do. We try to set up an agent that perform research and another agent that also reports. Present the research that was made by one agent as a document. And that was done within a split of let's say 2 minutes. What would take you, a normal human being, maybe 2 days to complete a good research work. With the aids of agents, agent can do that task just within a minute or two, and then you get what you want. And so we begin to feel that these agents can do crazy work that humans struggle with, especially if they are repetitive tasks. If there are tasks that have direction and have order, agents can do that easily. And today we just want to look at the anatomy of agentic AI, a roadmap to becoming an agent, an agentic AI. So here, okay, for today's demo, we will use Crew AI, which is what we use in the last class to understand an anatomy of an agentic AI to accelerate our deployments or our tasks, as the case might be. Let's first dive into what constitute the 7 layers of agentic AI. First, the goal and intent. Now, for Crew AI, Crew AI uses crew and tax. Look at the name, crew. Crew is more like, a collection of workers doing one particular thing. So if we have an organization, the people in charge of the running of that organization, they are more like a crew. And then each of the crew has a task to perform. And so the first part in the anatomy of agentic AI is the goal and the intent. So every crew has a task to perform. Then we also look at perception, task and inputs, task inputs and context. We have reasoning. Agents uses the LLM combined with their rule to reason. And then we also have external tools where they store memory. So we'll have a vector DBs action. Every agent have an action to perform. Some, it's meant maybe just to search the internet, or maybe to read a file or write to a file. And then as well, feedback, task chaining. So sometimes you perform, anyway, we'll look at these processes one by one. But first, we have the goal and intent, the perception, the reasoning, the memory, the action, feedbacks, and then control. We'll try to pick them one after the other as we proceed. So vibe shift. So we're shifting from talking to doing. Still, let me go back and introduce what we have before now. Traditional AI. When generative AI came up, maybe like ChatGPT or Gemini, if you are using them, you know that they are stateless and reactive. For the traditional AI, you must ask a particular question. You give it a prompt, and it will give you response based on your prompt. So they don't store anything. Well, the memory is a little bit there that can track your conversation, especially if you are using a page, and see what you have. But then it's stateless and reactive. It's based on the questions you ask that gives you. That you prompt it, it answer, it forgets, it waits for you to drive. So that's just about the LLM, especially like ChatGPT and Gemini. But for agentic AI, they're stateful, goal-driven, and proactive. So for an agent, I can tell an agent, perform a research for me on a particular topic. The agent will go ahead, create a plan for that research, a step-by-step guide on how he's going to achieve that. If I want, I can make it such that I don't have any say the moment the process begins. But most times, you will advise that, okay, let there be a human in the loop. So the agent tell you, this is my goal, this is what I want to achieve, and then you accept each response at each time as it evaluates. So you give a mission, it plans, executes, and learn. It drives itself. That's the power of agents. So the mission, that's goal and intent. Let's look at this. Without a North Star, agent drifts into hallucination. Explicit goals defines success metrics. So when you are defining your agent, you tell this is, you are to act as a researcher, for example. Let's look at what we have here. African context, Nairobi traffic analysis. So bad goals. So here we're asking the agent to fix traffic. Vague, because it's not directional. There is no particular task you are giving this particular agent. And this one can result to hallucination. But then if you want to drive an agent and make it successful, you give it definite goals. Be able to count the number of cars on a queue. If they are up to 10, then you can report that this is a traffic jam. Give it definite answers. So Agentic will analyze 2024 traffic data to identify peak congestion times in Westland. So here it is specific. You are trying to give it a direction. But when you define the task for agents and you don't give it direction, it's actually hallucinate. So your goal and the intent should be specific. So ingesting context, that's perception. The problem, the world is messy with PDF, API signals, messy group chats, and the rest. Perception layers normalize raw, noise into structured variables. Yeah, so what the agent can do at some point is that it can rearrange your messy data and put it into a word that you can understand, a clean context. So we have an example here. Messy realities. What the agent can do is it can rearrange this into order that you can understand. Okay, maybe there are several data. It can tell you, okay, these are PDF, these are Word documents, these are APIs, these are charts, and the rest. So it's a matter of cleaning the raw data you bring. Reasoning and planning. This is also the core part of the agentic AI. So the brain, we have in the last class, we did discuss about the brain of the agents. Like we said again, the brain of the agent is LLM. They use the LLM to reason. Remember, the LLM are trained on a very large data set. And so the agent use the LLM as the brain, as a guide to plan. It breaks goals into steps, evaluate options, and anticipate outcomes. This is where autonomy is born. So crew implementation, we have just a simple task here. So if you look at this, this is an agent. The agent is acting as a data analyst. It has a goal here. The goal is extract insights. Now, the backstory normally is more like what an agent is meant to do. So here, expert in statistics. So that is the role the agent is playing. And these things need to be specific, and then clear for an agent to act and then you to get the results you want. So key insight, Crew AI uses rule-based cognitions instead of open-ended dynamic planners. It is simple and more controllable for business logic. The four, memory system, solving the goldfish problem. Here we have long-time memory and then the short-time memory. Agents also use this. Remember, the human brain also use the long-term memory and then the short-term memory. Things that, when things are stored in the short-term memory, within a short time, you might forget them. But when it is stored in the long-term memory, even for a long time, you can still recall what you think about. So, short-term memory are context windows. What did I just search for? What is the current step? Just these are just short-term memory, but long-term memory are vector database. Now, for long-term memory, you are no longer just storing them in a context window. You are storing them in a vector database or a rack, as the case might be. Now, so RAG is it retrieves all the data of African origin football players starting from year 2000 up to 2026. So if you have this information, that is a long-term memory because anytime you make reference to anything, what the agent does it goes back to the memory and then retrieve record. For example, I could have even a PDF, the information I need on a PDF, and query information from that PDF using an agent. The PDF serves now as a long-term memory. So tools, use, and action, interacting with the world. Now, for Creo AI, there are several tools you can use. So here, you can use tools like File Writer. You can use tools like search tools. We use one in the other class that searches the internet to get inside. You could also use APIs that convert documents to PDF or to Word or to any format that you feel comfortable with. So agents don't work, they work with tools. So for every agent that you want it to work, you will give it a tool. Now, executing action via API calls, code execution, file edit. This is how thinking turns into real world impact. So we could give an agent a tool, for example, SAPA, SAPA Dev. SAPA Dev is a tool that searches the internet. So an agent could use SAPA Dev to go through the internet and get results. Then maybe a reporting agent could now use the report generated, present a clean, executive report or a summary or whatsoever you want to achieve. So Creo AI to use is constrained, auditable, and deterministic, highly suitable for production environment. Now, some other agents don't use, some other agent even uses voice. So you could have a record of a voice and agents pick that voice, use it as a tool to make calls, for example. But we do not have that voice tool for Creo AI, but other agent, other platform uses the voice tool as well. Feedbacks and learning. Sometimes you want to perform, could be a research. Or let's take this scenario in a customer service setting. Sometimes the customer service staff will maybe try to answer a customer concern. After you answer that customer concern, maybe the QA, the quality team, will try to review your response to how well you answer that customer. Was it empathetic? Was it based on the standard of the company policy? Does it suit what the customer wants? Did you get the response? The answer or the query of the customer right? Now, these things make the customer service agent learn that next time I'm going to be careful because I know QA will check my emails if there are grammatical errors, if the English is correct, if the goal that the customer wants to achieve, I met it right. Now, for agents, you could do that concurrently. One agent serves as a customer support, drives an email or a troubleshooting guide for a customer. The QA immediately will track, look at it, and make observation. The agent will go back within again, correct it, send it back to QA. QA make changes again until they get to a final stage where the QA will feel, oh, this is great one. It addresses the customer's question and it is professional, it is empathetic. Once the customer gets this, he gets his results. So feedbacks, agents also iterate. You can make your agents iterate over a particular task until you get a good response. Remember, even for large language models, if you ask ChatGPT one question now, it will give you a response. Ask it the second time to give you a little different response. Ask it again, it gives you a different response. Now, it knows that this thing might not just be getting what you want. And the good thing about this LLM is you can even get feedbacks as well. You can tell it, no, this response is not correct, or this response does not satisfy what my curiosity or my query. So it goes back, try to refine it. It learns from this. So observing outcomes and updating plans based on success or failure gives the agent a guide to to the response if it is correct or not. So AI implementation, task chaining. So you with one task, you can give a response, it checks and see if it's correct, it goes back again in that chain until you are able to get the real response you want. But this can be done with human in the loop. So a human is reviewing the response and say, oh, this is correct, or this is not correct. Or I don't want it in this language. Remember, you can tell an LLM or you can tell an agent to speak to you in a tune of maybe Socrates, the language that it uses, or Shakespeare language. Maybe it's a literature you are writing. Yeah, so until you are satisfied with your response, you can answer, okay, yeah, this is good. This is what I want. With this, even in research, different the STEM has a way they write their report. The science base, the arts know how to write their research. So you can pick maybe one author that you know that it's popular and has his work online and is visible by all. You can tell the agent to write in the language of that particular researcher, the way the researcher writes his work, because maybe you are making a research around, let's say LLM, for example, and then you know one father of LLM that you have read the research work and it's aligned with what you want to achieve. You can simply tell the agent, do this research in the language of this particular person. Because he's getting it from the LLM, it's able to tailor the language of that person and then give you your reports. So CrewAI optimizes for workflow integration, that is repeatability, rather than autonomous safe modification. This is safer for enterprise use. Now, this you can make your agent to be autonomous, but for now, we keep saying that let there be a human in the loop. So the human review the response, check what it's all about. Is the response in order? Is it what I want? Does it meet my goal? Because if you just allow the agent to be autonomous, the agent writes the way it wants to write, and whatsoever it feels comfortable, it gives you. So it's best to put human in the loop so that the agent can review whatsoever you are doing. Control and governance. So Guardrails, which is also very important because agents can pick anything. And even for our LLMs, we have Guardrails. Guardrails are set. For example, if you are trying to ask ChatGPT about violence, it will tell you I am not trained to answer this. If you try on maybe ChatGPT and say, teach me how to rub, you can try it and you will tell me the response. So it will simply tell you that I am not trained to perform this task. So you can set guide rails. For example, no violent communication when you are setting your agent. No violence. Don't answer questions that relates to violence. Don't answer questions that relate to self-destructions. You are trying to set up guide rails so that you know that the agents are controlled. Remember, if we are building AI agents, it should be what is controlled and based on standards and not what we call destruction. So safety boundaries, permission, cost limit, ethical constraints, autonomy without constraint is a liability. So when building agents, we must be sure that we have limits to our agent. They have limits. They have, boundaries. Not everything the agent should do. You could try to train your agent to just answer medical questions only. So you set that as one of the guidelines. Don't answer any question that is outside medicals. And it should not be violent. Yeah. It tries to answer. We have one simple here. So explicit orchestration processes. We are saying it should process. It should be sequential. What the agent will do is two agents, agent one and agent two. They are performing sequential tasks. It means that one perform a task, hand it over to the next for check. So system architecture, the multi-agent crew, how specialized agent collaborates. So what happens here is user give a request, it meets, gets to an endpoint. Here, it's trying to tell so we have different crew. For workflows, for example, like multi-agent workflows like this, for example, you could decide to say, okay, I have a workflow that I could say, give me the recent happening in agentic AI. Now, you could split this crew into different. Maybe one is just searching the internet, one is reporting, another one is creating a LinkedIn post based on the report, another one is creating a blog, maybe posting it to your website based on the report generated, and then maybe you could have another one posting maybe an Instagram video based on all the same reports. This all forms a crew with just one prompt. Give me the recent happening agentic AI. One make research, one report. So the other three agents, one pick it, post it to LinkedIn, one post it to your blog, maybe your website, and another maybe create a video, an Instagram video. Doing that just within a short time. But what are they doing? They are using shared LLM resources. So maybe you picked ChatGPT, for example, as the API endpoint is using, or the LLM, or you pick Gemini. What they are doing is they are still using one shared LLM resource and then sourcing this information and presenting it the way you expect. So, assessment and applicability. What we are trying to look at here is agentic AI without chaos. So when you're building your agent, you should be sure that your agents will respond to the way you want it, or how well they respond to your query. So agentic AI is not ideal for self-improvement autonomous agents, self-improving autonomous agents, open-ended exploration, because there should be a specific goal, like we said from the beginning. So it's not something that you could just go outside board. That's why we keep saying that the agent cannot replace the human brain. The human brain can think. I don't think there's a limit to how the human brain can think, but the agent have limit because it's trained on a limited data, even though it is vast. It's only what is documented and the large language models have access to that the agent can reason on. So open-ended exploration might not work for agents, but then it work for human. Black box creativity writing. Now, of course, you know that black box creativity writing too, it's more like an open-ended exploration because sometimes it's not directional. Sometimes it's decisions that are critical and stored at high levels. So agents are not good for this particular task. They are not good for self-improvement, improving autonomous agents, open-ended exploration, and block creativity. So if you come from a data science or enterprise system, through AI design choices offer the power of agency with safety of structure. So it's excellent for data pipelines and research, business automation, and multi-role AI teams. It's not good for voice. You can't use Creo AI to create agent that uses voice because that's not integrated yet. Maybe we're hoping there could be improvement, but Event Lab uses voice, yes. So you could choose Event Lab. Remember, there are several other platforms. Event Lab is one of them. Uh, Landgraph, AutoGen, and several others. Many are coming up. So you could review based on what you want to achieve.